PowerPoint and begin the talk. A minute. Thank you again so much for this opportunity and for the chance to talk a bit about the work we're doing at IBM Research. And in particular, we're looking at talking to the technical community about how we build AI that we can trust, how we build AI that tackles and overcomes issues such as bias, limitations of transparency, etc. So I'm Tabi, and I manage our AI and content research at IBM Research here in South Africa, Johannesburg. And part of the presentation I'm going to give today is work that comes across IBM Research, not only in South Africa, but across the world. As you know, some of you that we have labs, IBM Research laboratories around the world in different continents. So I'm going to present our perspectives and our view of what it means to build AI that we can trust, what it means for us to trust AI, and also provide some resources that would be beneficial for the technical community, but also share some of the work that we're doing at IBM that can be immediately leveraged by other people wanting to build trustworthy AI systems. So I guess, one thing that's very clear is that more and more we're seeing AI powering more and more critical workflows across different sectors, from banking, government, legal, healthcare, and in several other domains, as we all know. And therefore, it becomes more and more critical and essential that we focus on trust. We focus on, from the inside out, how do we build AI that is trustworthy? So one of the key questions then is, what will it take? What does it take to say that the AI that we build, the AI that we deploy, that we sell to customers is trustworthy? And I'll speak of 4 principles, and in detail, I'll get into each of them. But we're speaking about fairness and avoiding bias within AI. We're looking at explainable AI. We're looking at safe and robust AI, as well as the transparent, use of data, as well as the transparent application of AI systems. And one aspect I won't touch on at all in this call is the section here on stakeholder communities, because we believe that it takes more than just the core technical teams or the core developer communities to make AI trustworthy. And as much as I will only talk about the technical aspects of how we build trustworthy AI, it's important to always reiterate how the bulk of the work sits in the broader community, including policymakers, including different levels of engagement across borders, across nations, etc. So I will begin with the key questions again, just reinforcing what I just said last in terms of when we say we have built an AI system that is trustworthy. The key questions are: is it fair? Is it easy to understand? Is it transparent? And I'll explain what all of these things mean. Is it accountable? And importantly, also, this is the point of robustness. Did anyone tamper with it? Is it safe for use? Is it attack proof, and so on? Okay, so let's start with the most common topic when we speak of fairness in AI, which is the topic of fairness and bias. And I think when we started as a research, as a global technical community to realize the challenges with AI, one of the first issues that came out was that of fairness. And some of the early examples that many of you may remember were, for example, the facial recognition systems a couple of years ago, where they were immediately, it became apparent that some of the facial recognition systems, even those that were being used in practice and in production in some really critical domains, were not trained in data that was representative of the general population. Basically, then it wasn't fair to people of certain facial features, as an example, or perhaps people of a certain tone, and most of that was linked to the quality of the training data. My bad. I don't know. Oh, sorry. But it goes beyond that. Now we're beginning to realize that sometimes, the question of, is the system fair? it can even go to about not only in the training, but also in the way that it is deployed. As you can see from this first image here, is a system is unfair if, you know, it can place a certain group or a certain type of user at a systematic advantage or disadvantage over another. And as we know, you know, the other big question is about imbalanced training data, non-representative data, incorrect deployment, etc. So these are things that we have to think about when we train, when we deploy, and when we continue to use AI systems in practice. Another sort of key question on the question of bias is, it goes beyond the data. You could, as I was showing, that there are components of how AI systems are deployed as well. Another interesting issue is the fact that even into evaluation of the systems, bias can creep in. And here it happens mostly because as humans, we all know we are inherently biased because of our upbringing, because of the environment that we've been exposed to, because of our culture, etc. So we as humans carry a certain influence, a certain bias within us. And that bias can creep into the way we evaluate AI systems. So it's absolutely critical that, you know, even with seemingly complete and representative data, that we pay attention to our own human biases in curating data sets, in evaluating those data sets, as well as in evaluating the fairness of the systems that we deploy. So these are some resources that I'll just touch upon quickly that anyone can go on and look at. There's quite a lot of research that is going on, and some of the outputs of this research are immediately usable. An example is this particular paper here that presents a data scientist's guide to discrimination-aware classification. So if you're working on a classification task, for example, this is a very good guide into, you know, developing a discrimination-aware or a more fair classification algorithm. Another one, this is currently, it's an online textbook on fairness and machine learning. It is still being developed further, but it's quite a good resource as well for people working in the technical, you know, building of AI to look into. And it covers a number of topics that are worth looking at if one wants to, you know, pay attention to the fairness of the machine learning work that they do. In addition, then from IBM Research specifically, a couple of years ago, IBM Research released a toolkit. It's an open source toolkit called AI Fairness 360. That's the URL. It's available globally. It includes you know, tutorials, demos, examples of, you know, for different types of data, for different types of machine learning algorithms, right? Looking at in practice, how do we actually, you know, apply the principles of fairness. It includes, you know, content on metrics, over 70 metrics of how to, you know, determine the fairness of a machine learning model. And it includes tutorials that show how to mitigate bias in different types of AI applications. And for those of you that are also working on sort of production AI systems as well, there are several products that IBM has. As an example, IBM Watson OpenScale. This is a product that is available for IBM clients to use to plan and train the AI models, and it gives the developer visibility into every step of the AI development lifecycle. But importantly, it incorporates then within this planning and this development questions of how to incorporate fairness. So I believe using tools like this, then, you know, it gives more and more resources into the hands of AI developers to make sure that, you know, they think about fairness during the time of development. And so I'll move on quickly to the second pillar, beyond the first one having been fairness and mitigating bias. And the second is in order to build AI systems that we can trust, it requires accurate and understandable evidence. The AI has to be explainable. And I'll give an example. If a doctor is using an AI system in a hospital, right? And the system recommends a treatment plan. the doctor wants to understand why that treatment was recommended for their patient, right? They don't just want to know the answer or the recommendation, because they need to know, they need to trust it. And the way to trust it is when you know how it has been formulated. Similarly, if a customer goes to a bank to apply for a loan and the loan is denied, and such a decision is made by a machine, then for the customer, it doesn't, they can't trust that decision unless they understand the way in which this particular system, this intelligent system, has made such a decision. And it goes all the way to, for example, in the classroom as well. If teachers will be evaluated using AI systems, if AI systems will be used to create students, etc., the teachers, the students want to know how and why AI systems are recommending, advising, predicting the way that they do. And it goes along in almost all the domains and sectors where AI can be applied and deployed. So again, looking at what can people do, right, to ensure that the AI they build is explainable. One of the things is that with AI, it tends to be tempting to look at the primary metric of success as accuracy, right? As developing systems that work, developing AI that does what it's supposed to do. And often that means, using black box deep learning models. Sometimes that means using transformer models because they are the best for the task. And sometimes there's challenges like limited data. And then, then the solution is to find whatever architecture will work for that particular context. And we acknowledge that all of this is true. However, then there has to be an extra deliberate step of thinking about, no matter what data set we're using, the size of the data set, or the type of architecture or machine learning approach that is being used, how do we incorporate explainability, right? Sorry, how do we incorporate explainability into the model? And again, IBM Research has released another open source toolkit. This one is called AI Explainability 360, and it is a resource that helps developers and data scientists to include a capability for diverse explanations into the models that they develop. Similarly, this one also, it has demos, these papers that describe the basic concepts of explainability, as well as live tutorials that one can look at and sort of examples of actual models that had explainability embedded within them. Now, another example also of an IBM product that supports a step of explainability in the model development, open scale as well. It allows the model developer to incorporate aspects of explainability into their model development. Now, going to the third dimension of what does it take to have AI that we can trust. Then the third dimension here is AI, it has to be ethically bounded. We have to feel safe that this AI cannot be tampered with. One of the clearest and maybe funniest examples of a non-robust AI system happened a couple of years ago, in 2018, when some ill-intentioned group of people wanted to throw an internet joke of associating the word idiot with ex-president Donald Trump in the United States. And what they did is they went to sites like Reddit and other sites that are populated mostly with user-generated content, and they uploaded multiple photos of Donald Trump, attaching the word idiot as a caption in all of these images. What then happened was that the Google search algorithm at the time then picked up this content that was populating across the web, and if you went to Google Images and searched the word idiot, then immediately you would get all the top results as photos of President Donald Trump. That's an example of, at the time, a limitation of a system, limitation of an algorithm that got fooled by the protesters in this case. Many of the AI algorithms that are in production now are very, very safe against these types of attacks from ill-intentioned individuals. But we need to make sure that the system we build are safe from those types of attacks, from being fooled in terms of the data that we use to train and give results from the AI systems. So this is an example of again, why we must question ourselves about the validity of especially user-generated content when it is being used as training data. Many of us use Twitter data, for example, to make decisions to understand different phenomena. And it's extremely important that we know and understand that it's possible for Twitter users to maliciously, put a certain narrative in that trends of tweets, and unless there are ways that are build the robustness steps, then the AI systems we build or train on that data are inherently flawed. The second thing is beyond flawed data that is falsified by humans. There's also the possibility of bots, or the models or the AI algorithms being exploited in other ways, and we need to make sure that all of that are protected, especially for systems that are deployed for public human use. So then again, if you look at another toolkit that IBM Research is working on, this is called the Adversarial Robustness Toolkit. And this one in particular is looking at how do we begin to look at adversarial machine learning? How do we begin to build robust machine learning algorithms such that then the systems we build are protected from different types of attacks? There's several, and you can sort of look at, if you go into this particular toolkit, you can look at, the different, I don't know why this keeps advancing themselves. You can sort of look at the different approaches, the different techniques that and the advanced methods that are included. There's lots of papers, examples again, and also tutorials that one can follow. So the fourth dimension now, remember I spoke first about fair and unbiased AI. I talked about explainable AI. I spoke about safe and robust AI. Then the fourth aspect that IBM Research is pushing for is that of transparency. Okay, so explainability is one thing. We want to make sure that if needed, right, we can give an explanation of the algorithm. But another dimension to that is we should be transparent about it. It's one thing for the explanation to exist, but we should actually be transparent about communicating that inner working mechanism of the AI or the machine learning algorithm to the users or to whomever will be the consumer of the systems that we build or train using AI. If you think of, as an example, in the food industry, the food manufacturers are required to produce or be transparent about the ingredients and the health nutritional facts of the food that they produce. If you think of electronic and appliance producers, they also have to be accountable about the energy use of the appliances they produce. If you think of pharmaceuticals, right? Every medication you buy, it comes with detailed information about the drug, etc., about the risks associated with using the drug, as an example, about guidelines for use, about possible side effects around the composition and the active ingredients and all of those things, the interactions that can be expected from said drug. Similarly, looking at how integral AI is coming to be in our personal lives, in our places of work, our places of business, etc., it is increasingly important that we as AI producers develop what we as IBM are choosing to call fact sheets, where we actually declare the conformity of our AI systems to fair, ethical, and responsible AI, but also where we communicate the inner workings or the most critical information and warnings, if applicable, of the systems that we produce. So there's a great paper, the one that I've included here that sort of speaks to the initial argument for why this is important and why we think it's something that in different formats, of course, companies and different groups should try to imbibe. So again, if you think of the fact sheets of a complete AI or a system with AI component at some point, the facts will come from different levels of the system production. Everything starting from the business owner, the data scientist, the software developer, each of these levels, they inject a certain level of mechanism into the product, and it should be clear to the end user what is inside or what is the core functionality of the product in as much as is likely possible, but importantly to describe the conformity of the product to, as I said, principles and the elements of fair and ethical AI. I think I've already spoken a lot about this in terms of the fact sheets includes input from different individuals in the product lifecycle. So again, this is the last toolkit that we're introducing from IBM Research. So for each of these 4 principles, IBM Research is working actively to ensure that we have toolkits that the public can use and they can refer to, they can see examples of how these principles are in practice applicable in a real life, like in a live AI development situation. So if you look at the AI Fact Sheets 360, similarly, you will find some papers that describe what we mean by fact sheets and why this is important and why more people should actually look into adopt this type of transparent communication of AI, as well as there are some examples of different types of machine learning algorithms, and seeing how these examples include some fact sheets that we think are useful to accompany a system or a model depending on where it is deployed. And so as I conclude, I think I've spoken about the 4 principles to say what it means to build AI that is trustworthy. And for each, I've sort of provided some resources from IBM Research that anyone can use and even contribute to if possible or if desirable. And the first is AI should be fair and unbiased. AI should be explainable, right? And AI should be safe and robust. And in deploying and using AI systems, we have to be transparent around what they are and how they actually work. And all of these 4 things we should be doing with the understanding that even if it means delaying a project, we need to pay attention to these 4 principles. Even if it means not taking the shortest route to the highest accuracy of the machine learning model, these 4 principles are what will ensure that AI becomes trustworthy. The systems we build and deploy are trustworthy by our customers and the users in different contexts. So thank you very much. I think that is the end. I have included here my email address if anyone would like to come into contact with me. But yeah, thank you very, very much.